6.10, and this unit here is literally just exactly what the name of it is, which is just integration using long division or completing the square. So there's two things that we need to learn in this unit. It's going to be the long division, right? How do we use long division to integrate? And then the other thing that we're going to learn is how is it that we complete the square? How do we complete the square to integrate? And let's say complete the square. Right? How do we complete the square? And how do we use long division in order to integrate? Now what's going to come up, and this is going to be very relevant, we went over in the last problem I found out, or maybe a few videos back, we found out that the derivative of arctan of x is 1 over 1 squared plus x squared. But really what I want to do is generalize that a little bit more, and we really want to remember these antiderivatives. So what do these antiderivatives say, and how could I use it? And I'll just do a quick example of how we need to know what this means inside and out, and how we need to know what this means inside and out. So here, right, in this first one, and the telltale sign that we're going to want to use this is when you see that that square root on the bottom in the denominator. So this one says basically if you have it where it's 1 over the square root of, let's just say for arguing, 2 squared minus x squared. Right, and I want to find the antiderivative of this with respect to x. Well, I just find out how this matches the general. So in this case, 2 is a, u is x, and I have that it's arc sine of 2 over a. Oh, sorry, 2 over a. I apologize. U over 2, I'm sorry, again, x, because what took the role of u? X. And then a is 2. I apologize for that. Plus c. And then that's that. I'm thinking about how to teach the other parts. Okay, now, this here. I go, and I have this integral 1 over, right? This is going to be maybe, let's do another example, 4 squared plus x squared, right? We need to identify this as then just being this one, and there's no square root in this one, right? It's just, first of all, it's a sum, right? That'll give it away. And it's something squared plus something else squared. Now it's with respect to u here. In dx, it's just going to be arc tan x over, and in this case, a takes the role of 4 plus c. And that's generally, how we would apply these rules in the simplest of cases. Okay, in the simplest of cases. And we need to kind of really know these two here in order to be able to do this. Now, how does this come up? So I think it only comes up in this last one over here, the application in this case. But definitely for when we complete the square, are these two going to be of relevancy? And I'll have them written again when we do that one. But let's now just focus right now on the long division, which only this one I think is necessary. Okay, so how do we do this? Okay, we could be asked to find the antiderivative of a rational function, where this is a polynomial on the top and then this is a polynomial on the bottom. And if you want to find the antiderivative of a rational function, it's a good idea to try and divide. So we just need to know how to do this division even when the powers are the same. If the power on the bottom is greater though, then this will not work. So don't even bother. So in this case, in all my examples, right, the power on the bottom is equal to or less than, right, the power on the top. The power on the bottom here is 1, the power on the top is 1, the power on the bottom here is 1, the power on the top is 2, the power on the bottom is 2, the power on the top is 3, so forth. Okay, this will only work if the power on the bottom is of lower degree. So now let's see. So I have it where it's of lower degree. Let's do this division. So I'm going to do 2x minus 1 into the 4x plus 4. And we have to remember that I got to do the 2x into the 4x, which is just exactly 2. I distribute the 2 to get 4x minus 4, minus 2, I apologize, minus 2. I subtract these two things. 4x minus 4x is 0. 4x minus negative 2x is positive 6. And now the degree of my remainder is less than the degree of the divisor, so I'm done. This is my remainder. Okay, and the remainder, I just write the whole thing now as 2 plus 6 over 2x minus 1 over the divisor, the remainder over the divisor. And this expression should be equal to the original, and you can check for defined values of x. 0 is a good one. 0 should give me 2. 0 gives me not the same thing in this one. So what does 0 give me? 0 gives me 8. No, 0 gives me 4 over negative 1, negative 4. I apologize. And then 0 here gives me negative 6, negative 4. Right? So 0 and then negative 4. I apologize. Yeah, so it looks good. So I plugged in x as being 0. And I got 4 over negative 1 for this, which is negative 4. And then here I get 2 plus 6 over negative 1, which is negative 6. 2 plus negative 6 is negative 4. I got the same thing in both. So that's good evidence that I did the actual division correct. And now I just want to find the integral of this right here. And what you get is you're going to get that the antiderivative of 2, or the integral of 2, is just 2x plus 6 times the antiderivative of 1 over 2x minus 1 dx. Now, in this case, and this is where we start to really gotta be able to think about what's happening here. In this case, right, I need to do further a u substitution if I really want to see what's happening. So u is equal to 2x minus 1, that whole bottom piece. And then I get du is just 2 dx, right, derivative. And I substitute into this, right, so let's bring it up here. Let's just find this one integral. Integral 1 over u, right, so I'll substitute if I can, right, and then dx is just 1/2 du. So it's the 6's in the front, so I got 6, and then now it's 1/2, so the 1/2 is going to come out, du. And now I have the antiderivative of 1 over u, which we should know is ln absolute value of u plus c. So the 6 became a 3, and then now I have that antiderivative right there for this one piece. I plug this in to here. I'm going to get my 2x plus 3 ln absolute value. And I'm actually going to change out what u is. U is 2x minus 1. So 2x minus 1. And then the plus c. Don't forget the plus c. And this is your antiderivative. You can check by probably taking the derivative of this, and you should get back 2 plus 6 over 2x minus 1. And yeah, that involves a decent amount, right? First we got to divide, then we got to do the substitution. So it requires some decent understanding. Now this one, same thing, same idea first, right? It's a rational function. Good tip, good indication that I probably want to do some long division. The degree of the bottom is less than the degree of the top, so I do this division. So I get 3x minus 1, and I'm dividing that into 3x squared plus 5x minus 3. Okay, so how many times does 3x fit into x squared? Well, how many times does 3x fit into 3x squared? Well, x times, right? Then 3x squared, when I distribute the x, minus an x, and I subtract the whole thing. This is going to give me 0. 5x minus negative 1x is 6 x's. I bring down the minus 3. How many times does 3x go into 6x? Well, positive 2 times. 2 times 3x is 6x. 2 times negative 1 is negative 2. Subtract the whole thing again. 6x minus 6x is 0. Negative 3 minus negative 2 is negative 3 plus 2. I get negative 1. Negative 1, that's just a constant. It has a lower degree than 1 to this x. So this is now my remainder. I write it as x plus 2 minus, because it's a negative 1 over the divisor. 1 over 3x minus 1. And this is what I'm integrating, dx, right? I just did some algebra. I just did this division, right, for this rational function and wrote it like this. Now that I have this, right, I can find the antiderivative of x. That's just x squared over 2 plus the antiderivative of 2 is just 2x. And then now this, again, minus, and I want to do minus. This here again, if you notice, right, I want to just investigate what the antiderivative of 1 over 3x minus 1 dx is, right? I again want to make it look like 1 over u. I want to use the antiderivative of 1 over u is ln absolute value of u. So u here in this case is going to be that 3x minus 1. Du is 3 dx. And then I solve it for dx, and I see that it's 1/3 du. And now I substitute everything in. You're going to get 1 over, instead of writing 3x minus 1, I write just u. And then instead of writing dx, I write 1/3. Right? I write 1/3 du. Right? I changed out dx for 1/3 du. The 1/3 I put outside. Now it's 1/3 ln absolute value of u as my antiderivative. I should put a plus c. U is 3x minus 1. So it's 1/3 ln absolute value of 3x minus 1 plus c. And you could come up with a general rule, now that I'm looking at this, for finding these ones here. So you see in both of these problems you had that u substitution where it turned out to be an ln. So I think that as long, so what would be the rule? So the general rule would be if it's ax plus b, right, some linear thing on the bottom, what's the antiderivative? So let's do this in a different color. Let's do this in a very special color, maybe like, oh, I don't know. Is this a good color? All right. So let's see. Let's get a special rule before I even attempt this one over here. So before I even attempt that one, let's start with my special rule. Okay, so special. That we can memorize like we do for these intervals, right? So the special rule could be, I want to find the antiderivative of 1 over ax plus b, because this will do it for all of the cases, right? It'll take care of this integral right away, this antiderivative, and this antiderivative, both of which I ended with in this problem. So I ended with an antiderivative like this, and I ended with an antiderivative. This is the rule for both of them, right? Watch. So dx. So what is it going to be? U is just going to be ax plus b. Du is then the derivative of this with respect to x is just going to be a dx. Then you solve for dx. Dx is going to be 1 over a du. And now I substitute. So now I get the integral 1 over, instead of writing ax plus b, I write u dx. Instead of that, I'm going to factor out a 1 over a. I write du. Now I take the antiderivative of 1 over u, that's ln absolute value of u. There's the 1 over a here, plus c. And the last but not least step, I go back for what u is, 1 over a ln absolute value of ax plus b plus c. And we could have used this rule now for either of these two integrals without doing the u substitution. as long as I memorize this rule, and it's up to you whether you want to memorize this rule or do the u substitution for each one of these. So now, if I have any antiderivative of this form, right? So now let's see. So what takes the role of a in this first case? Well, a takes the role of 2. And what takes the role of b? -1, right? So what did I get? I got that it's going to be 1 over, right? In this case, right, I'm using this here, 1 over 2, right? 1 over 2. So let's see, where is it? Oh, here's my 1 over 2. But I forgot. Okay, there's a 6 in front, so be careful, right? There's this 6 in front that I factored out in the beginning, so it really is that just this part was 1 over 2 ln, right? And again, it's going to be the same, ln a of 2x minus 1 plus c, right? And it's just the 1/2 in the front, right? And that's all I got was the 1/2 in the front. And then I multiplied it by 6 to get this 3. And similarly, what's going to be this integral? So let's use this one. This one will be more direct because I think I just wrote out the answer I did. Yeah, exactly. So what takes the role of a in this case? What takes the role of a? Well, where is it? Oh, here we go. What takes the role of a? The 3. Right? And then b is -1 again. But that's sort of inconsequential because if you look at this, right, it's 1 over 3 ln a is 3 and b is -1, so it's -1 plus c. And that's exactly what I got, right? This is the, where did I write it? Here. And then I substituted down there. But okay. Yeah, this is your special rule. You could use it or you could just do the u substitution each time. I'll do the next one. This one we'll do in the next video.